Okay, so back with another online lecture. So this one is going along with a lesson for properties of elements. So I will choose, let's do red today. So we talked about a few things in class. We might, I'm recording this beforehand, so we might actually take these notes in class. But if we haven't, or if you're absent, we talked about the atomic mass, which is the mass of a single atom of a element. Now, elements can have atoms that have different masses. And we're going to learn about this in a future lesson in a concept called isotopes. So like there can be oxygens that weigh different amounts, but we'll get into that later. So the atomic mass is the mass of a single atom, whereas the average atomic mass is the average mass of all the atoms of an element as found on Earth. We don't have enough data to know if anything changes on other planets, but we're pretty confident that we have the average mass of all the atoms of the elements that we found on Earth. Now, we obviously don't weigh every atom, right? We just take a representative sample of a substance and get the average mass of those atoms. And this is usually measured to a few decimal places. We're going to max out at 2 decimal places in this class. Most of the time we will use 1 or 0 even. Okay, so elements have an average atomic mass. We also looked at reactivity. So this is a property that describes how a substance will react with other substances. So we saw this on the cards in terms of did things react with water, right? Certain things reacted with water, certain things did not. So that's the definition of that's their reactivity. Now, this is what's called an intensive property. And we discussed this a little bit earlier. So it doesn't matter how much of the material you have, it's going to have the same reactivity. So a huge amount of copper, like a room full of copper and a thimble full of copper, will have the same reactivity to different substances. So I'm going to read through this and then I'll let you guys copy it down on your own time. So this guy Mendeleev, considered the guy who created the organization of the periodic table. He obviously didn't create the elements themselves, but he figured out how to organize the periodic table, and he based them on things like reactivity and atomic mass. Now, he didn't get it perfect, but he had it really, really good for the information that he had. So Mendeleev's arrangement of the elements helped to predict the existence and properties of as yet undiscovered elements. So there were gaps, significant gaps in Mendeleev's periodic table that he couldn't quite reconcile. But what he learned was that there should be things that go in those gaps. There were elements that people hadn't found yet in nature that existed, and he could predict based on the gaps that he had in his periodic table. So it was a powerful predictive tool. Okay, so wrapping up, how is the periodic table organized? Now, this periodic table is going to be like your best friend in this class because you're going to be using it. You'll use it for every test. You'll use it for your homeworks. You'll use it all the time in class. So get to know it well. And how is it organized, which is the question we were studying? Well, Mendeleev organized his periodic table based on properties, like we talked about a second ago, specifically reactivity and atomic mass. And just reminding you, you don't need to write the wrap-up in. This is putting it all together. This can help you write your summary, though. So elements in each column of the periodic table have similar properties. So for example, lithium, sodium, potassium in the first column of the periodic table are going to react in the same way. We talked about reactivity, and it shows how it will chemically combine with other substances. Also describes the speed. I didn't put that in, but the speed of the reaction, whether things go quickly or slowly. And Mendeleev helped predict the existence of undiscovered elements through his arrangement of the periodic table.